Welcome to Campus Conversations with the President. Today we're speaking with Professor Kathy Ensor, professor in our Department of Statistics. Kathy, welcome.
Thank you, David.
Now, you recently got a lot of attention, I think, for a study that you did with some others, drawing a link between ozone levels and heart attacks outside hospitals. And I wonder if you could maybe start by just telling us, how you got interested in that and how that project evolved.
Certainly. So I've been looking at air quality in Houston since mid-90s, since being at Rice for a while. And I have collaborated with Lauren Rahn, who is one of the co-authors of this study, for at least the last decade. And she worked for Mayor Bill White. And so we've been involved with air quality in Houston for a while. And we had the opportunity through the Houston Endowment to take a look at cardiac arrest, 911 calls in Houston, and see if that correlated with ozone levels. And so David Purse, who is head of EMS for City of Houston, is a collaborator on this project as well. And so we pulled together the data and the research that's been done all over the world. And Lauren did a great job of pulling all of that together. And we decided to try it in Houston, and we did find a significant result. So it should lead to certainly improved community-based services and warnings for the city and individuals who have issues with cardiac arrest should be paying attention to the ozone levels and the warnings that come out.
So out of this study, there are real consequences for how resources should be allocated, how people should make decisions about their own activities and health.
Yes, and so actually the Air Houston and there's actually going to be an announcement tomorrow about a new app that they're working on, which gives you the level of ozone anywhere in the city at any point, and so you can download that to your iPhone and just be personally aware of your circumstances. And we're hoping to partner with them going forward to help them improve their spatial mapping of ozone. And so the study has really strong consequences and practical endpoints.
So, a lot of people have certain skepticism about statistics and sort of, you can prove almost anything, you do the study the right way. What were some of the challenges in this data and looking at other possible causes that you had to deal with to really come to the conclusion that it was the ozone levels and not some other thing that might be causing these heart attacks?
So it's a very carefully done study, and it's using a design called a case crossover design, where individuals actually serve as their own controls. So what you want to do in any type of study where you're trying to assess a cause is to have a control. And so this design allows for that sort of fundamental scientific question that you want to answer: what is the typical level? And then we were able to control for things like temperature and all the other meteorological issues that you would normally expect with cardiac arrest as well. And so all of that is part of our study, and so we feel like we've isolated the impact of ozone on cardiac arrest through this fairly careful design. But I agree, you really do need to be careful with your statistical analysis and with your study design, and also answering questions that have some other scientific base. So we're not just dreaming this up. There is a medical reason that there could potentially be this link, and so.
So you actually, your interest spans some really distinct areas. And maybe to take a step back, and I'd be curious, how did you originally get interested in statistics, and how did the particular areas that attracted your attention, how did you get involved in those, and what's been interesting and exciting to you about that?
Oh, wow. So as a fairly young undergraduate, I was extremely excited about both mathematics and computer science in my early days, and and saw an opportunity to bring both of those interests together in the field of statistics. And I was correct. And so having joined this discipline, 25 years ago, that's exactly what's happened. And so it's still, so I'm able to develop really new methods and think deeply about problems, and then bring those methodologies to answer real questions that are of interest to people.
So let me ask you about another sort of perhaps less weighty use of the statistics. We just, of course, recently had a Super Bowl, and we ended up with one brother coaching against the other brother, and the folks at the Chronicle, I guess, came to you and said, what are the probabilities? And that's such a question people are always kind of asking themselves as they encounter some coincidence or something. They say, what are the probabilities of this? So here this problem landed in your lap. What did you find that interesting, and what were some of the challenges in actually concluding? What was your conclusion about the probabilities that one coach would end up against another coach in the Super Bowl?
Well, so my absolute probability is like 1 in 11,000, but it depends on how you frame the problem. And the biggest challenge to that question was the timeline. I had maybe 3 hours to come up with the answer. And so the number one issue, and it's how we teach our students to think about these complex problems, is to break them down into a series of assumptions and a series of steps. And then once we have those assumptions, then the probability models just follow from those assumptions. And so that was the hardest part of the problem, was framing the problem. What is the likelihood that you would have two brothers coaching in the NFL to start with? What is the probability that they would be in two different leagues? What is the probability that they would be in the bigger pool of coaches that get chosen to be NFL coaches? And my results actually assumed that everything was equally likely, but we know that there's family history to professions, and so that wasn't taken into account in my 3-hour answer. But there's always a more sophisticated answer.
So you went back a certain level, but what it is the father did and how that might affect whether both of his sons ended up coaching.
Yes.
That you didn't go back.
I did not go back, but it's clearly part of the problem, and so in statistics, that's what we do. We frame the problem. We have a fixed set of assumptions, and then if we want to come along and enrich those assumptions and enrich the solutions, then we're able to do that.
I've heard some people say that if there was one area of mathematics that everybody should know, every citizen, it's statistics. Do you agree with that?
Yeah, actually, of course, and yes, I actually naturally agree with that, because it is a language and a way of thinking that really helps us understand what goes on in our day-to-day lives, and just as citizens of the world, we use it continuously, so we should understand it. So.
Well, I think on that note, we'll conclude. Kathy, thank you so much for joining us for this edition of Campus Conversations, and thank you for joining us, and we hope you'll join us for our next edition. Thank you from Rice University.